Welcome to our today's class. Today focus on application of function, differentiation of functions. And in particular, we will be looking at two key functions, that is the revenue and the cost function. Now, suppose my P is equals to f of Q, where P is the price of the unit, while Q is the output levels. Now, P, usually call it, this function, we usually call it the demand function of a product. Now, when you have something like that, then the total revenue function, what we call the TR, can be given by the levels of output, which is Q, times the price per unit, the quantity demand, the price at the demand level. So this is Q times P, which is equals to Q times F when you replace the P in the function. So it is given by that. Now, there is what we call the average revenue function. So the average revenue function is simply the average of the total revenue. So to get the average, you simply take the total revenue and divide by Q. That is the quantity demanded. Now, TR, you have said we can take the quantity demanded Q times the P, and P was equals to F of X. So if you cancel this and this, it gives you F of P, F of Q, meaning that the average revenue is exactly equals to P. So this implies that the average function or the demand curve of a product are always the same. That is what I'm trying to say there. Now, given the average function as this, and somebody tells you calculate the total revenue, then you just take the total revenue times the TR. So it is Q times Q here times the total revenue, which is there, and this is that function there. So when I multiply the two, 4 times Q is 4Q, and this time this is 1/5Q squared. You can always sketch it because you know how to sketch. On the contrary, if you are given TR, then to get AR, it means you have to get TR over Q. That is how you get the AR as indicated there. The cost function is basically a function of the costs that we incur to produce a certain level of output. And there are what we call fixed and variable costs. There's fixed cost like labor, fixed cost like rent, fixed cost like material if it is not varying. But that is if it is fixed. But those which vary, the variables which are today different from tomorrow, the cost is varying, are the ones we represent like this. And the average cost function, again, similar to the average revenue, is the total cost divided by the quantity produced, Q. Now, when you look at these two functions, the total revenue and the total cost, you can work out the profit function. Now, the profit function we will denote it by pi, and that profit function is equals to simply the total revenue, the revenue you have collected, minus the cost that you have incurred then to produce that function. So it implies that the levels of the profit changes with changes in the levels output. But when Q is equals to 0, simply tells you that the profit is actually 0 because you have not produced anything. Now, how then do you maximize the profit? Because in every business, the whole idea is to maximize profit and minimize on the cost. Now, to maximize profit, what we do is that we first get the profit function, as I've shown you. Once you have gotten the profit function, you differentiate the profit function. You get the d pi dq, the d profit dq. Now, then you equate that derivative to 0, and then you solve for q, and then that will be the value at which the profit of that organization is maximized. Now, suppose the the profit function is given by that. At what point, at what values of Q is the profit maximized? Now differentiate this. Now, when you differentiate this, the 2 comes in front there, then you reduce the power by 1, get Q, minus the 6. This is Q. When you reduce the power, it is Q raised to 0, so it is 1. So it gives you the derivative of a constant is always 0. So it gives you that. And this is what we are equating with 0 here. When you put it with 0, when you simplify, it gives you that Q is 3. Meaning, I'm implying that this profit, it is maximum at 3. If you draw it, you realize that either it curves upward or it curves downwards at the point 3. That is where it is maximum. Let's work out some 2 examples here. Now, suppose you have been given a function, this one. The total revenue function of a firm is this. And the cost function is this. Now, let's work out the AR and the AC. To get out the AC, to get AC, simply divide TR over TQ. So you simply divide this function over Q. You divide it there over Q, and you realize that that is a function that you get. To get average cost, divide total cost over Q, and this is the function that you move there, and then divide it with Q, and that is what you get. Now, work out the values of Q that TR is maximum and TC is minimum. Now, TR is at maximum if you get the derivative of TR. So you get the derivative of TR with respect to Q. Now, you are differentiating this function here. This function is what you are differentiating. So the first, you start by 3, because Q, the power is 1, so it reduces to 1, minus this power of 2 here comes here, so you get 2 over 2, which gives you minus 1, and then the power of Q is reduced to 1, so it gives you Q. So you quit with 0, and when you solve, the total revenue is maximum at 3. Now, total cost, come here, take this function and differentiate. So Q raised to 2 is the 2 comes in front, so you get 2Q minus 5, because the Q here will go to 1, and 3 will go to 0 because it's a constant. So you get this, equate with 0, simplify. So the total cost is minimum at 2.5. Now, what is the profit function? Now, to get the profit function, you get TR minus TC. So you take this function here, subtract this function here. So I will have 3Q minus 1 over 2 Q squared plus 5. Then I subtract Q squared minus 5Q plus 3. Now, the part that is as no square, it is 3Q minus 5Q. So that gives us 8Q. The other one is minus 1 over 2Q minus Q squared. So it's a minus, giving us more addition. So you get minus 1 over 2 minus 1, giving us 3 minus 3 over 2. That's why I have minus 3 over 2Q here. And the other one is plus 5 minus 3, giving us that. So that is the profit function. So to get the value at which the profit is maximized, differentiate this function here. You get 8, The 2 comes down, so the 2 cancels with the 2, you get 3q. You quit with 0, you get it is maximized at 2.5. Thank you very much.